Hey, did you know that Mr. Newbold graduated from Utah State University? Go Aggies! So something special. Can you read it? So right about there it says magna cum laude. Magna cum laude. Woo! What's that, Mr. Newbold? That means I got only 2 B's and all A's. Woo! So my counselor told me to take geology. Like, oh, that'll be easier than physics. I should have took physics. Because physics has a lot of math in it. I'm good at math. Why did they say that? So watch out when you go to college. Maybe listen to your counselor there, maybe not. Do your own research, honestly. Because my counselor led me astray a couple times. Made me take calculus again when I already aced it in high school. I don't know. So make sure that you do your own research. Don't rely on college counselors. Nothing against them. Just led me astray. Okay, so we are looking at today, we're looking at 9.2. So 9.2, we got some review going on. Do you remember how to condense logs? Pause me. Try number 1 on your own. Pause me. Try number 1 on your own. I'm waiting. I'm waiting. Do it. Do it. I'll give you a hint. Do you remember you put the powers? Do you remember you put the powers back into position? Put the powers back into position first. So log base 3x to the 4th power minus log base 3y to the half minus log base 3 2 to the 3rd power. Nice. Now, do you remember what subtraction becomes? What does subtraction become? Division when condensing. So now we condense all 3 logs. You remember? So we have x to the 4th power, and subtraction becomes division. So then we have y to the 1/2 power, and also subtraction becomes division. We have 2 to the 3rd power. And so that can be reduced even more. So x to the 4th power divided by, basically the way y to the 1/2 power is the same as the square root of y. And then 2 to the 3rd power is 8. Nice. There we go. Okay, what is the exact perimeter in inches of the isosceles right triangle whose hypotenuse is 8 radical 2 long? So that's 8 radical 2. And so we've been learning something recently. And we've been learning that this is a 45, 45, 90 right triangle because it's isosceles and it's a right triangle. And if the sides are the same, then the angles are the same. Whoa, 45, 45, 90. So the shortcut then is that you just divide by radical 2. And that means that this is 8 and this is 8. Way-o. Because we divide by radical 2. So you take your 8 radical 2 basically and put it here. And then we just learned 45, 45, 90. We divide by radical 2. It gives us 8 and 8. So now we're trying to find the perimeter. And so it's 8 plus 8 plus 8 radical 2. Whoa, I hope you try this one on your own. Stop copying me. That's cheating. Not learning anything. If you copy from Newbold, don't copy Newbold. Okay, keep on trying your best on these with graphing. Yeah, you know how to do exponential? Do the base number first. Just graph that first. And then is that left 3 or right 3? Can you remember? So the x minus 3 is going to be right 3, opposite what you think, and then down 1. So give that one a try. Ooh, you remember how to do radicals? If you don't, you could do an xy table. And so if we do like 0 and 1 and 4, that would be the square root of 0 is 0 and 1, and the square root of 4 is 2. But we've got a 2 in there. Uh-oh. What's the opposite? What's the opposite of times by 2? Divide by 2. 2 are x values. So that would be 0 divided by 2, 1 divided by 2, and 4 divided by 2. So that would still be 0. That would be 1/2. And then that would be 2. And the x values stay the same. 0, 1, and 2. Cool. Don't forget to shift down as well. So our parent function is 0, 0 over 1 up 1 and over 4 up 2. That's It's our parent function. But now, do you remember how to graph radicals? So now we're going to go down 3, 1, 2, 3. And then that's our 0, 0. And now we're going to go over half up 1. So over a half up 1. And over 2 up 2. And there's our new graph. Woo! Nice. Goes a little bit higher. So our domain is from 0 to infinity, including 0, to infinity. And our range is going to be from -3 to infinity. Cool. So you give a try on number 4, give a try on number 5. Thanks for being here, guys, and helping me both. Yeah. Shout out to the janitors of Weber High, they're the best. Woo! Okay, so then, ooh, this is a good one. I'm glad you're watching my video to get some help with this part. So an angle with its initial side coinciding with the positive x-axis and the origin as its vertex is said to be in, do you remember? So that's said to be in standard. That's to be in standard form. That's to be in standard form or standard position. Standard position. Two angles that have the same initial and terminal sides are, so we're talking about like 30 degrees, for example. But then also if you go around 360 and then you go 30 more, that'd be 390. Thanks, guys. Peace out. So that would be coterminal. They both share the same terminal. So that would be coterminal angles, right? That would be coterminal. Coterminal angles? Coterminal. Cool. Two angles have the same initial and terminal sides are coterminal. Cool. Okay, draw each angle in standard position. Find and label the reference angle. Say which quadrant the terminal side lies in. Not too bad, not too bad. So we're going to go ahead and draw. Ooh, yeah. We're going to go ahead and draw here. So we have 30, 60, 90, 120, 150. There it is. Going by 30s, going by 30s. Okay, so that's the standard position for 150 right there. That's the standard position all the way to there. And then finally label the reference angle. So the reference angle, and say which quadrant the terminal side of the angle lies in. So the reference angle is basically the small angle to the x-axis, right? So right here, yeah, right there, that's the reference angle. So if this is 150 and this is a full circle 180, you would basically do the difference of those two. So 180 minus 150 is 30 degrees, 30 degrees. So the reference angle then, the reference angle is, reference angle is 30 degrees. And say which quadrant it's in. So the reference angle is 30 degrees, and of course that's in quadrant 2. So remember it goes 1, 2, 3, and 4. So those are the quadrants. Those are the different quadrants. Nice. So then you try number 10. That's a good one. That goes round and round and round. And try number 9 when you're at it. Woo! We'll try number 9 with you, but we're going to pause it first. Number 9. Negative 120 degrees. Go. Go, you got this. So go ahead and do negative 120. Go to graphic, go to graphic. Do you know how to do it? We'll do it in red because it's going down. So all the way to here is negative 90 degrees. So 30 more would be, that's right, there's your negative 120 degrees. So that's the terminal standard position. Now the reference angle again is going to be the small angle that it makes right here. That's the reference angle. It's always positive. So the reference angle is always positive. Cool. Okay, so if that's negative 120, how much more do you get to 150? negative 180, right? How much more? How much more? 180, so 60 degrees, right? 60 degrees there. Cool. I think you're getting the hang of it. What if we did have something crazy, like, I don't know, 315 degrees? That'd be crazy, right? So 315 degrees would be all the way to there. If this is 360, then we're looking at that difference again. This is just a side note, or we could say extra notes, basically. So if it goes all the way to there, then what's our reference angle? So our reference angle, again, is the small angle to the x-axis. The small angle to the x-axis is the reference angle. That's the reference angle. Okay, so what would that be? 360, how much more? 315 to 360? Is that what, about 45 more? Because 4 or 5, yeah, that's up to 60. So 315 plus 45 would equal 360. And so 45 then is the reference angle. 45 is the reference angle. Cool. And this one is 60, and this one's 30. This one's 60 degrees. This is the reference angle. So now you try. You're gonna have to go around more than 360 now. So go around 360, and the next one would be what? Plus 30 is 390. Keep on going, keep going. You got this. Okay, so now determine two coterminal angles. So easy peasy lemon squeezy. So to find a positive coterminal angle, you would just add 360 to it. And so 114 plus 360 gives us 474. So 474 is the correct answer, but also, smiley face, there are infinite coterminal angles. You can just keep adding 360. So 834 is a positive coterminal angle. 1194 is a positive coterminal angle. 1554 is also a positive coterminal angle. Yeah, there are infinite amounts of positive and negative coterminal angles, right? Yeah, there are infinitely many. Infinitely many positive and coterminal angles. Infinitely many. Cool. Okay, so how do we find a negative coterminal angle? Well, now we just go ahead and take 114 and you minus 360. Minus a full circle, basically. And you could minus it again if you wanted to. 114 minus 360. The closest is negative 246. So negative 246 degrees is correct, as well as positive 300, as well as 474. Our two answers. Those are our two answers. One's a negative coterminal angle, and one is a positive negative coterminal angle, and the other one is a positive, we'll do blue, a positive coterminal angle. Cool, so you try number 12, Remember that there's infinitely many. So you could find more negative coterminal angles by minusing 360 again. And again, and again, and again, and again, and again, and again, and again. Negative 2766. Negative 2766 is another negative coterminal angle. Okay, given that cosine 29 is this number, that's this number, that's this number, to 4 decimal places, find the following without using a calculator. So they just basically want you to find the positive or negative coterminal angle, and then just use the answer as the decimal. So we're going to take cosine 38.9, we're going to take 389, and we're just going to go ahead and minus 360. right? Because we're gonna find another positive coterminal angle, but we can minus 360, it'll still be positive. So this is still a positive coterminal angle. Because it's not negative, it's positive. Okay, here we go. So it's going to be 389 minus 360. So 389 minus 360 is 29. So that's going to be 29 degrees. And we know what cosine 29 degrees is. Yeah, we got it right here. Yeah. So the answer is just 0.8746 is the answer. Way-oh, super easy, super easy. This one you might have to minus 360 twice. Maybe. So 749. I'll let you do this one. So minus 360. And do we have to minus it again? Yep, minus it again. Minus 360 again. Gives you 29 again. Same answer. So you have to minus 360 twice on that one. And then this one, you're probably going to have to add 360, right? Add negative 311 plus 360. Beautiful. Just double checking. Want to make sure we're getting this right to you. Okay, beautiful. Okay, beautiful. Are we halfway? I think we're halfway. Woo! Yeah, we'll do one more and then we'll do our next video. So now I want you to draw a reference angle and find the trig ratio for the angle if possible without using a calculator. Come back in about just 10, 15 minutes.
I could come back at like 5 or so.
Is that okay?
Yeah.
I'm just doing a video right now.
Yeah.
I mean, I can pause it if you need me to.
What?
I can pause it if you need me to.
No, that's fine. I'll just come back at like 5.
Okay, thank you.
Yeah.
Appreciate it. Okay, draw a reference triangle and find the trig ratio. There we go. Without a calculator. Okay, so give it a try. Here we go. We got 60 degrees going on, which is right about here. So that's 60 degrees, 30, 60. Ooh, this is a 30, 60, 90 degree triangle. You need that information to do these problems. So we're going to go ahead and draw a triangle like that. Beautiful. And so we know with the 30, 60 right triangle, 30, 60, 90, that our hypotenuse is always 1. And then we go from our hypotenuse to the short leg by dividing by 2. So we take our 1 down there, because we're going bigger hypotenuse to smaller short leg, divide by 2, right? Remember, from hypotenuse to the short leg, you divide by 2. Cool. And then to go from the short leg to the long leg, what do you do? What do you do? What do you do? You take your 1/2 and you times it by radical 3. Radical 3 times bigger. Remember, short leg to long leg, radical 3 times bigger. So that's going to be over 1. Multiply straight across. Multiply straight across. So we get radical 3 over 2. And so this will be radical 3 over 2. So now, what is cosine of 60 degrees? Well, across from 60 degrees is opposite. And then here's adjacent is 1/2. And here's the hypotenuse. Hypotenuse, HYP, hypotenuse. And since that's the hypotenuse, right? Sorry. Since that's the hypotenuse is equal to 1, the hypotenuse is equal to 1, then we can go to do cosine. And so cosine again is what? It's adjacent over hypotenuse. And adjacent was 1/2 over the hypotenuse, which we said is 1. So the answer is just 1/2 as your answer. Does that make sense? Hope that makes sense. Let's do some more and make sure you get good at it. That was an even one. You're supposed to do that one on your own. Okay, let's go to number 17, because that's a toughie. Okay, here we go. So where is sine of negative 135 degrees? Ugh. So that's going to be negative 90. So we're going to keep on going, keep on going. So that's going to be negative 120 and then 135. So we're going to go minus 30 degrees more and then minus 15 degrees more. And so that right there should be the right spot for our angle, because negative 90 plus negative 30 plus negative 15 should be Yep, negative 135. Okay, so now we're going to draw a reference angle. So this is going to be our triangle right here. So we do it in orange. Let's do it in orange. So here's our triangle right here. Here's our right triangle. Okay, so because that's 135, what's our reference angle? So our reference angle is going to be going negative 135 and negative 180. What's like the difference of those two? How do I go from 135 to 180? It's either 30 or 60 or 45. I'm going to guess it's 45. So negative 135 plus negative 45 would be negative 180. But the reference angle is always positive. So this is a positive 45 degrees, right, between those two. And again, the reason, why won't you raise? And the reason why is because, so this is a 45, 45, 90 right triangle. And so even though it's an M, those two together, the difference is a negative 45. Reference angle is always positive. Always positive. Yeah. So what does that mean? It means positive 45. And since this reference angle here is 45 degrees, the other side is 45. Because that's to add up to 180, that triangle. Okay, so there's our triangle, there's our triangle. So if you remember my triangles there, we have a hypotenuse of 1. And then we have to go from the hypotenuse to the leg. And if you remember for 45, 45, 90, when you're going from the hypotenuse to the leg, you have to divide by something special. You have to divide by radical 2. And then we have to rationalize the denominator. So we're going to go ahead. Remember 45, 45, 90. Remember 45, 45, 90 right triangle. Special. Special. Do you remember? Do you remember? It's a 45, 45, 90 right triangle. And you're going from the hypotenuse. So if you're going from the leg to the hypotenuse, you times it by that special number. Remember? You times it by, what the? That's not right. You times it by that special number, which is radical 2. So times it by radical 2. But if you're going from the hypotenuse back to the leg, then you divide the radical 2. So that's basically what we're doing right now. We're going to go ahead and divide by radical 2. So we went ahead and took the 1, and we divided by radical 2. Okay? So take that 1 and divide by radical 2. Now we can't have a radical in the bottom, so we're going to times radical 2 to the top and bottom. It's called rationalize the denominator. So multiply straight across, we get radical 2 all over. 2 times 2 is 4. And what's the square root of 4? The square root of 4 is 2. So that means that this is radical 2 over radical 2. And this is radical 2 over radical 2. And then that's the hypotenuse. Okay, what is sine from our angle? Okay, so this will be the opposite side. And this will be the hypotenuse. And so it's opposite of our hypotenuse. So again, sine is opposite. Sine is opposite over hypotenuse. And so that's going to be opposite, which is radical 2 over 2, divided by 1. And so our final answer is just radical 2 over 2. Woo! That was a tough one, but we helped you on it, brother, sister. We helped you on it. Okay, stay tuned for our next video. Thanks for watching. See you soon. Thanks for watching. See you soon. Bye for now.